Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Here are the three given column vectors u, v, and w. We will add them and form a second combination, then explain a hidden dependency between them. The tasks: compute u plus v plus w, compute 2u plus 2v plus w, and explain why all three vectors lie in a plane by finding scalars c and d with w equals cu plus dv. Pause and think. If you don't know the answers yet, you'll get the satisfying insight very soon. First, add u and v component-wise to get the column vector -2, 3, 1. Adding w to that sum cancels every component, giving the 0 vector. So u plus v plus w equals 0. Double the earlier sum u plus v to compute 2u plus 2v, yielding -4, 6, 2. Adding w gives back -2, 3, 1, which is just u plus v. So 2u plus 2v plus w equals u plus v. From the zero sum, we rearrange to express w as -1 times u plus -1 times v. This finds the scalars immediately. So the coefficients c and d are both -1. Because w is a linear combination of u and v, all three vectors lie in the span of u and v. U and v are not scalar multiples of each other. Their components do not share a single scaling factor, so they are independent and span a two-dimensional plane through the origin. Thus, uv and w lie in that plane. Let's wrap up what we found. First key fact: the three vectors sum to 0. Second, 2u plus 2v plus w equals u plus v. Third, w is a linear combination with coefficients -1 and -1. Great job following along. Watch the next video to learn more about linear dependence, spams, and geometric interpretations. It'll be fun and a bit nerdy, and a bit